We spend billions of dollars building sophisticated firewalls and complex encryption algorithms, but the biggest vulnerability in any network doesn't come from a flaw in the code. It comes from us. Untrained and uninformed human beings are the primary target for modern security breaches. Look at this cyber attack flow model. You can have a hardened server node actively inspecting traffic, but a well-crafted phishing email slips right past the technical defenses and goes straight to the human user node. It exploits trust, not software. To actually secure a system, we have to look at what we're protecting. This 3D architecture shows the 4 layers of any computing device. At the base, we have the physical hardware, the memory and disk drives. Above that sits the firmware. Then comes the software, like your operating system and applications. And finally, the electronic data you generate. Notice this firmware layer in the middle. It's often invisible to the user, but it acts as the permanent bridge locking the physical hardware to the software layer above it. If an attacker compromises this bridge, they control everything built on top of it. You have to map out these physical and digital components before you can design a defense. Knowing exactly what sits inside the machine dictates the tools we use to protect it. This graph maps the 5 goals of security. At the center is the CIA triad, ensuring confidentiality, integrity, and availability. Supporting that triangle are 2 pillars: control, which limits access, and audit, logging actions to monitor what happens inside the system. When controls fail, the damage scales rapidly. This infection chain tracks the fallout, starting locally with the deletion or theft of your stored data. Attackers often go further, hijacking your computer to form a botnet. The chain extends outward, taking control of your email to distribute malicious links to contacts, leveraging your identity to bypass their skepticism. A compromised machine doesn't isolate damage to a single user. It turns the victim's hardware into an active weapon pointed directly at their network. Lock down your environment. Harden the operating system. Automatically download security patches. Close 0-day vulnerabilities immediately. Always keep a restore point. This flowchart outlines how proactive antivirus software handles threats. It performs 3 distinct tasks: checking files against known signature databases, actively scanning core OS files for manipulation, and intercepting unauthorized network requests before they execute. Even with software monitoring, hardware fails. Maintain multiple backups across external drives and cloud services to guarantee availability when the primary system goes down. A standard user account prevents major software installations, while an admin user has full override capabilities. If a program tries to install, user account control acts as a toll booth, requiring manual approval before changes are written. This BitLocker visualization addresses physical theft. If someone steals your laptop and boots their own OS to bypass the password, an encrypted drive scrambles readable data into ciphertext. The external OS reads nothing but noise. Patching the OS, limiting permissions, and encrypting the drive builds a rigid inner defense. If an attacker holds the physical hardware, data remains completely inaccessible. This network topology maps incoming traffic. The firewall enforces strict rules, allowing green packets through while bouncing unauthorized red ones away. Next, the intrusion detection system monitors remaining traffic, analyzing behaviors against attack signatures and generating logs to spot suspicious patterns. When connecting from an untrusted location, like public Wi-Fi, a virtual private network creates a secure, encrypted tunnel connecting your laptop directly to a destination server. Interceptors only see scrambled data. A firewall's blocking power, an IDS's visibility, and a VPN's encryption work together, stripping attackers of their tools before they can probe your local machine. This master architecture shows the final result: defense in depth. Every component functions simultaneously. The hardware is locked by encryption, the software is actively scanned by antivirus, and the network traffic is filtered and tunneled. When one layer fails, the next one stops the intrusion. This leaves us with a strict operational checklist. Automate your OS updates. Run active antivirus. Browse on a standard user account. Keep user account control enabled. Maintain offsite backups. Encrypt your physical drives. And route your network traffic through configured firewalls, an IDS, and a VPN. No single software application creates a secure environment. Security requires overlapping layers of defense, maintained daily by users who understand exactly what they are protecting.